Hello guys, welcome to Blender for Computational Design, Chapter 1, where we're dealing with parametric geometry. This is the video number 3. Today we're going to be expanding on our code, and instead of creating one random vertex, we're going to make multiple vertices, join them with edges, and hopefully make some cool looking abstract geometry that we're going to add a couple modifiers to make it look even cooler. All right. So before we start, there was a couple of things I wanted to mention. One is that Sefi, he's one of the main contributors of Sberchuk with over 3,000 commits. He um, observed that we've been using this refresh and reload every time we want to reload this code and run it. And there's actually a shortcut for it, which is Control Enter, and it does both at once. So this is very handy. And when you have a really large node setup, then this is going to save a lot of time. So just keep that in mind. And the second thing is that when we created in the directive, this is the directive or comment block where we're defining our input and output sockets. When we created the out vertex B, Sberchuk automatically made the vertex list for us. So this was automatically made by Sberchuk when we wrote this. So we can actually delete this line and the code should still run because as you can see it's running because it was made. So no need to do it again. Now also one more thing is that I wanted to show you guys this. This is the scripted node documentation in the official documentation. I'm gonna post the link. I think it's really interesting if you're liking these videos to give it a shot and look into it. Mainly, it deals with how to work with the UI. It explains the syntax that we've been looking into, how to make input sockets, output sockets. It also explains the socket types that we get, right? And we have a couple more things we can define. We're creating an input or an output socket, which is a default value. We can set up the nestedness. We're going to look into this, what does nestedness means a little bit later today. But this is a really good uh, picture of it. So keep this in mind. I highly suggest that you read the documentation or check it out at least and check these socket types, which we only been using these two, but there's many more. All right, so let's start. So in order to start, what we first want to do is instead of creating one vertex, we want to create multiple vertices. To do this, we're going to use a for loop. And to create a for loop in Python, we type for I in range 10 2 points, and then here we do something, which would be our code. So what the for loop does is that it looks into a list. In this case, we're creating a sequential list with the range function. So the range function is going to give us 10 values starting from 0. So it's a list of 0, 1, 2, 3, 4, 5, etc. So for I in, we can say 10 items in this list for each item. And this is a variable that is going to keep track of how many times we have run the code. So every time that the loop is run, this I keeps increasing 1 in the as a variable in our code. Sorry if this is a little confusing the way I explain it, and hopefully will make more sense when we do it. So right now, what is important is that if we indent our code, right, we already created this code to create one vertex. So if we indent it and put it inside our for loop, because right now what we're doing is that all this code is now effectively inside these for loops, so it's going to be repeated 10 times. So if I reload this, you can see now we have 10 vertices. So now I can just change this number, 105, load it, and then we get a list of 5 vertices. So this is really, really, really cool. Now, the next thing is, well, we want to be able to drive this range 5 value from our input here in the node that we are scripting. So in order to do that, let's go ahead and create a shift a number. So we're going to bring a number from the nodes. We need an integer number, a complete number, because we want complete vertices. And now, as I change this value, you can see I still get 5 because I haven't changed my code here. But as I refresh it and this socket sees that something got refreshed, it re reloads the code, so it creates a different set of 5 vertices every time. So the first thing we want to do is call these 6 into the code, this number input into our code. So let's give it a try. For I in range 5, now we already created the number, so I'm going to use the number variable and I'm going to refresh it. Let's see what happened. Okay, now we're frozen here, so I'm going to open the console and it says type error. List object cannot be interpreted as an integer. Our range function here, it's expecting an integer and we're feeding it this number variable that comes from here, this number input socket, which supposedly is an integer, 5. So let's see what's going on. I'm going to connect this socket to my node. And as you can see, we don't just have a 5, we don't have an integer, we have an integer inside 2 lists, right? So in order to access a value of a list in Python, what we have to do, I'm going to use real fast the Python console here. Say we have a list, right? List. This list equals, I'm going to be using 3 values. Let's say 5, 2, 6.5, right? So we created a list with those 3 values. And if I want to access these 2, so the second item, what I have to do is type list and then inside a bracket I put the index number. And if you recall, the index number is 0, starts from 0, 1, 2, depending which item is inside that list. So the number 2 is the second one, and the second one it's actually number 1 because we start from 0. Oop. So enter, and as you can see, we're printing that value, the number 2 that came from the list. Now, if we actually create a list of lists equals, right now what I'm going to do is I'm going to create a list with, again, I'm going to use the value 1, comma 5, comma 6. So 3 numbers again. So right now I created another list, and what I'm going to do is I'm going to list of lists dot append, and I'm gonna append my list. So if I print my list of lists, you can see now we have our values that we give in the beginning, 1, 5, and 6, 1, 5, and 6, and then we have an item, a complete item that has a list inside it. So we have a list inside a list. So nestedness is how many lists, because we could keep going. These 2 could be another list, and then there could be another list inside that one. So in order to access, again, let's try to access these same 2, or let's try to access the 6.5. So we have the list of lists, right? And then which item is our list? So it's our 0, 1, 2, 3. So it's the index number 3. And then from the index number 3, which is a list, I want to access, so I put a new set of brackets. I want to access item 0, 1, 2. So as you can see, I can actually access that 6.0 by using this syntax here. So the deeper you want to dive into the list, the more brackets you need to put with the index of each value that you're trying to access in every list. So uh, hopefully that's not very confusing. I'm gonna put also the documentation on that on the video, the official Python documentation, if you want to read more about it. So what I'm gonna do is first, as you can see, we have two lists, a list inside a list. So I'm gonna access the first item, which is 0, because we only have one element. And then on the side, I'm gonna access again item 0. And I'm gonna refresh this. Okay, it froze for a second because I think I need to click enter here. There we are. Yep, we're getting 5 vertices every time. And let's see, let me plug this back into the node so we can see our lists of vertices. What I want to be able to see if is now this number is driving the quantity of vertices we're making. So if I type 100, I should be getting a list of 100 vertices, right? And if I type, also one thing to keep in mind is that right now if I go very, very high, it's capped at 1024, so I can change this value by typing in these gears here, the minimum and the maximum value. So I can change these maximum and put whatever number I want and make as many vertices I want. I'm not going to change it right now because I don't want to deal with that many vertices right now. But just to keep in mind if you want to test something with more vertices. So, okay, so now we're driving our number of vertices from there, but we're still missing our edges. So if you recall on the line here, in order uh, oh, in order to create the edges, what we do is that we have two lists. So we have our list. Let me put it here. Okay, there is good. So we have two lists. Our first list, which is 0, well, x, y, and z, sorry, comma, x, y, and z, comma, x, y, and z for each one of our vertices, right? So this one is this one, this one is this one, and this one is this one. So if we look at our vertices, we have all the coordinates for each one. And now if we look at the edges, what we're telling it is in the second list, take for the first edge, we only have two edges, right? So we're going to have two items, item 0 and item 1 inside the edges list. So I want to plug in the number 0 item of my vertex list with my number 1 item. So we're taking 0, 1, right? And then the second edge is going to be made of the second item, which is 1, comma, 2, which is the third item. So all we're telling it is how to construct each edge by giving it the two vertices that are stored in our vertex list. So we're accessing the vertex list for the XYZ values, and the edge is only telling us which vertex is connected with which vertex. So 0 is connected with 1, 1 with 2, and depending on the shape or whatever, this doesn't have to be sequential every time. Now making it sequential, it's easier, and we're gonna actually do it sequential for our script today. But just keep in mind that we could actually be connecting 0 with 3 or with 2. You know, the more vertices that we have, the more the more we could connect with, right? So just remember that. And one more thing is that to remember is that for every, I'm gonna delete this mess. I'm gonna delete all this mess here. So for every vertex or vertex that we have so if we have three mm, vertices, we have two edges, right? And if we have four vertices, we're gonna have three edges. And if we have five vertices, we have four edges. So every time we have the number of vertices minus one. So in order to start doing our code for for making the edges, because right now what we need to do is tell it how we're gonna build the edges. Again, I'm gonna use a for loop for I in range, and same thing, I'm gonna use this same number. Now this number, the number of vertices is 5, but I need it to be 4, so I'm gonna put minus 1. So no matter what number we pass through here, every time is gonna take out 1. So what do we want to do every time? So if you recall, we need to create an edge, we need two vertices. So our vertex 1 is gonna be equal to I, and our vertex 2 is gonna be equal to I plus 1. So what we're doing is every time we run this code, the vertex 1 the first time is going to be 1, and the second time is going to be 2 and 3, you know. But then the second item is going to be 0 plus 1, then it's 1. So it's going to give us this same structure that we see here, right? So now we need to add this edge, or E equals, and then we can tell it B1 comma B2. And finally is we want to create a new output that we're going to call out edges of the type S. We're going to say edges dot append, and we're going to append this edge. So again, we created our edge, and then we're gonna actually append each edge that we each time we run this, we're gonna append each edge to our edges list. So E, and let's see if this is working. All right, so I'm gonna plug in this here. I'm gonna plug in this here, and we did got something for a second with edges. Something is, oh, if you recall, we need to grab this, and there we are. So we created a random, a range of vertices connected with an edge. And if we look into how we're building it, we have our vertices list on our edges list, and every time we add a new point, random point, we get a new edge added into it automatically. So now something that it's kind of a problem is that every time I'm refreshing this number, I'm getting a new set of vertices. And to control this, I'm going to use a function from the random library called random.seed. I can type any number here. You can type any number that you like. I'm going to use 10. And what this is going to do is that it's going to keep the seed the same for every time this runs. So instead of getting a new set of values every time we refresh our script, it's gonna use the same random numbers it pulled every time. I don't know if that makes sense, but what matters is that now if I change this value, I can make this grow um, little by little instead of it being popping all over the place and changing. Actually, I can control like it's organically growing. Okay, so now let's do something cool with this. We have our very weird looking mess of lines. So we can actually bake this and make it a Blender object. Gonna turn off right now the spreadsheet viewer. And I can now add a modifier to this. So I can go to add modifier, skin, give it some thickness, add a material. I have this like a very metallic red material, right? And then I don't know, maybe I want to go and add Shift a new kind to visualize it, which can be a meta ball. And actually, well, I'll do that in a second. So I'm gonna plug in the vertex list to the origins. And now as you can see, I'm getting a meta ball on every vert vertex that I have, right? So I can add a new material to that by selecting it here. So this node, the Metable viewer, actually creates an object automatically. So we can add a material to it and make it black. No. And now if I actually update this number, we get more metaballs. This one is not updating because we baked it. So I'm going to delete it for now. And what I'm going to do is I'm going to leave this off for now. Shift A, visualize, and we have this skin measure. So let's see how these work. I don't think I have used it before, so I'm going to play my vertices and my edges. There we go. So we're getting our lines made automatically, and it's creating an object also called alpha. So let's change these to vertex and these to edges. And now I can select my vertex here, change it to my black material, and my edges object and change it to the red one. So now if I change the number, it will grow. So just something to keep. Well, one thing that a problem that we have is that we have the old objects stay there. So I'm gonna delete them. I'm gonna delete this alpha and this other alpha. There we are. Sorry about that. But now we have control over this kind of cool looking geometry. So hopefully this is useful and you can use it in a project later. And I'm sure you can make a really cool looking render with this. So thanks guys, and we'll keep exploring more ways to make this kind of geometry in the following tutorials. So stay tuned and see you soon.